Okay, so today's lesson is the average rate of change. You actually have done the average rate of change before. You just didn't really hear that phrasing used. So today's learning target is I can calculate the average rate of change by examining inputs and outputs, and we're going to be looking at 3 different situations. We're going to be looking at a table of values, a graph, and a function. Okay. So when you find the average rate of change, you are simply finding the rate at which how fast the function's y values are changing compared to their x values, so your outputs and inputs. So above here we have a visual of y equals x squared, and we're looking at the average rate of change from 1 to 2 or 0 to 2, and we simply are looking at how fast those y values are changing in relation to x. So like from here, we're looking at it from 0 to 1, and we're looking at it from 1 to 2, and so forth. So the average rate of change formula is for each function y equals f of x between x equals a and x equals b. A and b are just numbers on your interval. Your average rate of change is the change in y over the change in x, which is also equal to f of b minus f of a over b minus a. A familiar way you've seen this formula is y2 minus y1 over x2 minus x1. It's just your slope. And the catchphrase that we could use is rise over run whenever you look at a graph. Note, average rate of change is a special name for linear functions only, and that is slope. The reason why we call it slope is because it's a special property. It's always going to be constant. So whenever you have a linear function, your slope is always going to be your average rate of change, regardless of what you're looking at, from 1 to 2, 1 to 3, 1 to 4, and so forth. It's constant. It's always going to be the same. So the first example we're going to look at, and we're going to try to use the average rate of change notation, so this notation right here, we want to find the average rate of change over the interval 1 is less than or equal to x is less than or equal to 3. So we don't know what the function's rule is, and guess what? We actually don't even really care. But we want to look at 1 to 3. So what I'm going to do is go to my table of values and cross out 0, 1 and cross out 2, 9. I only care about my 1, 4 and my 3, 16. So our rule is f of b minus f of a over b minus a. So we always go backwards, so we really want to do f of 3 minus f of 1 over 3 minus 1. We go to our table of values, and when we plug in 3, we get 16. When we plug in 1, we get 4. And now we do 3 minus 1. We can do this in our heads. What's 16 minus 4? 12. What's 3 minus 1? 2. What's 12 divided by 2? 6. Your average rate of change from on the interval 1 is less than or equal to x is less than or equal to 3 is 6. So that's the rate of change for my function on this interval from 1 to 3 is less than or equal to x is less than or equal to 3. Here's how we do the average rate of change by looking at a graph. It says we want to look at it on the interval of 1 less than or equal to x less than or equal to 4. So we go out to 1 and we plot a point. So we go out to x equals 1 and we go out to x equals 4. When we go to 1, we have this point right here, 1 comma 1, and we go to 4, we have the point 4 comma 2. They give us the function rule, but we don't know really how to work with radicals yet, so we're not going to even bother. We're just going to do it as if it were a table, a graph. So we know our rule is f of b minus f of a over b minus a. My domain, or my interval I want to look at, is 1 to 4. So I'm going to do f of 4 minus f of 1 over 4 minus 1. So when I go to my graph and plug in 4, I get 2. When I plug in 1, I get 1. All over 4 minus 1. 2 minus 1 is 1. 4 minus 1 is 3. So my rate of change is 1/3. So explain what the average rate of change means. This basically is just saying that my graph is changing for every one y, it's changing 3x. So it's basically saying my slope from 1 to 4 is up 1 over 3. Now, my favorite, the average rate of change by examining an equation. So, given the function f of x equals x squared minus 8x plus 9, determine the average rate of change of the function over the interval 2 is less than or equal to x is less than or equal to 9. So I want to plug these values into my function. We know our rule is f of b minus f of a over b minus a. So what we want to do is f of 9 minus f of 2 over 9 minus 2. Here's the thing, it's going to be very messy if you just do all your substitutions into the question. So what I like to do is I like to go to the side of my paper and do f of 9 and f of 2 separately. So I'm going to do f of 9 and that's going to be, everywhere I see an x, I plug in a 9. So I'm going to plug in a 9 for x squared and a 9 in for my 8x. Well, I can type this into my calculator or I can do my PEMDAS. 9 squared is just going to be 81. 8 times 9 is 72. And then I add 9. 81 minus 72 is 9, and 9 plus 9 is 18. So that's what I'm going to plug in for f of 9. So I have 18 minus something over 9 minus 2. Now let's find f of 2. We're going to do the exact same thing. We're going to make those substitutions just like we did before. But this time we're going to plug in a 2 everywhere we see an x. And again, you can use your calculator or you can do PEMDAS. 2 squared is 4. 8 times 2 is 16, so I have 4 minus 16 plus 9. 4 minus 16 is negative 12. Negative 12 plus 9 is negative 3. That's what I'm going to be substituting now. So I have 18 minus a negative 3. Well, 18 minus a negative 3 is 21. 9 minus 2 is 7. 21 divided by 7 is 3. What that is telling me is that my average rate of change over the interval 2 is less than or equal to x is less than or equal to 9 is 3. That's it. So you now need to master how to find the average rate of change by looking at a graph, a table, and an equation. If you have any questions, please email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.